Hey guys, it's Melissa and Katy again, here with your weekly dose of last weekend's stem cells. Just be forewarned, it's Monday, and I personally am having a Monday, so I assume I'll be making a lot of verbal mistakes in the next few minutes, so be prepared. Also, this is Season 1, Episode 5, and Melissa has a cool story for you first.
Alrighty. Oh, my rubber band just snapped. Oh, ouch.
I said it was a Monday.
Oh, don't you hate when that happens? It totally just snapped on my hand. Okay, well, right now we have a really cool video. So this live imaging of blood stem cells in a zebrafish is pretty amazing, and it comes to us from researchers in Boston Children's Hospital's stem cell research program. Katy turned off the sound because I'm a much better narrator.
Yeah, the narrators on this video sound like they're scientists, which obviously as a scientist I think is bad.
It already been known that blood stem cells bud off from cells in the aorta, then circulate in the body until they find a niche and where they're prepped for their future job creating blood for the body. So for the first time, the researchers reveal how this niche forms using time-lapse imaging of naturally transparent zebrafish embryos and a genetic trick that tagged the stem cells green. So you can see them right there in the video, they're green. So what's happening is the newborn stem cell attaches itself to the blood vessel wall, then squeezes itself through the wall into a space just outside the blood vessel. So the stem cell is cuddled, and a nurse cell actually helps keep it attached. And the cuddled stem cell will then divide, and one of its two daughter cells will leave the niche. Eventually, the stem cells leave and begin colonizing their future site of blood production. Woo! And in this one, it's in the kidney.
This is the most scientifically minded cartoon I've seen in a very long time.
Yeah. Alrighty, Katy's got the next story. Let's see if we can. Oh, look, it's swimming.
Oh, I was like, it is a zebrafish. Look at that. That's what you said. All right. So this next story is about a study done in cell transplantation where they were looking at cells derived from amniotic tissues. And they found that as they were looking at this, and this whole study to me is kind of like, we already knew that. Because we know that in amniotic tissue, you're going to find two kinds of quote-unquote stem cells. They're likely going to be some epithelials, some kind of progenitor epithelial cells, and mesenchymal stem cells, maybe some hematopoietic stem cells. But we know mesenchymal stem cells from extensive, research and in the literature are well established as being anti-inflammatory. So it is not surprising to me that they found that the cells from the amniotic tissue had immunosuppressive properties. However, I love that they concluded that further research in an animal model needed to be conducted. Meanwhile, people are using amnion tissue in surgery today on people.
Should probably look into that.
So someone needs to be reading their labels.
All right, our next story is scientists from Singapore. They published a study that suggests that an autologous PRP hydrogel restores left ventricular structure in a pig model. So the scientists created myocardial infarction. Yes, yeah. I can never say that with a straight face. Was created. And 36 Yorkshire pigs were divided into the following test groups. So the first test group was they used a hyaluronic acid-based hydrogel. The second one, they used autologous PRP. The third one was ascorbic acid-enriched hydrogel combined with IV ibuprofen. The next test group was the PRP with the full compound, and they used antioxidants, anti-inflammatory factors in the hydrogel. And the last was saline as the control. So the one with the PRP and the full compound group, it had better left ventricular fractional area change, ejection fraction, and smaller LV dimensions in the control group, and the blood vessel density was higher as well. So the authors concluded that this hydrogel with the PRP and the full compound has the potential to structurally and functionally improve the injured heart muscle while attenuating adverse cardiac remodeling after acute myocardial infarction. I wonder if they ran the piggies on some treadmills too, just to check out their
part function.
Yeah, I had to do that with mice once.
Nice. I just keep thinking how funny it is that, you know, bacon gives people heart attacks and we just gave pigs heart attacks.
Aww.
It was in the name of science, y'all. I'm
know.
sure they were treated well, aside from the whole forcing a heart attack thing.
Don't YouTube right now those like cute little videos on miniature pigs.
Oh, they're so cute. Why did you say that?
Oh, it's okay. We're not gonna YouTube it.
Let's move on to this other thing that seems to be really disturbing you. Melissa is very concerned about this story.
Okay, the next story is pretty terrifying. Katy doesn't think so. But a new study suggests that low, brief BPA and other estrogenic compounds exposure can hamper the development of stem cells as well as lower sperm production. Watch out, guys. Watch out for the BPA. The researchers had exposed some newborn mice to BPA and some newborn mice to BPA to a synthetic estrogen used in birth control pills and hormone therapy. So the authors wrote that these exposures cause permanent alterations to the stem cells responsible for sperm production. Hasn't it been reported in Austin that the water has a lot of estrogen in it?
I mean, maybe it does, but what's really entertaining to me about this is I'm actually not particularly worried about sperm cell production myself.
Katy's confessions.
As far as estrogen causing permanent changes to stem cells, I think we've all experienced what PMS looks like. That does not surprise me, okay?
I think we have a caller calling in.
So this next story is kind of interesting to me in that it became a story in the first place, because this is basically a news release about an experimental surgery that was done in China on someone with a spinal cord injury. And they took mesenchymal stem cells and put them in kind of a collagen scaffold that they described. The way they described it, it sounded a little bit like carbon nanotubes that people might be familiar with, but of course they're probably not quite at the nano level. But the idea was to bridge the gap between the injured area of the spinal cord and the two ends on the sides to reestablish communication between the brain and, you know, the stuff that wasn't getting communication below the injury. So the surgery apparently took 4 hours and was done on the 16th of January. So we literally have no results. And this is just an announcement of, hey, we did this surgery.
Well, not us, but...
Well, I'm quoting them. Anyway, it's an interesting study, and, you know, I'll be excited to see the results of it. But I think similar things have been done before. Although, when they say that it's the first of its kind, it might be the first time it was done in China. So, that's fair. Moving on.
Alrighty, guys, last story. So our next story is on scientists that use stem cells to model neurodegenerative diseases like Parkinson's and Alzheimer's. So these are the most common neurodegenerative disorders that they have proven particularly difficult to model, either in animals or in vitro studies. However, scientists are starting to find a way around this, right? Life finds a way.
Always.
So the thought is this. So if you can find a way to model the cells and study them, you can then find a way to treat them. So scientists created induced pluripotent cell lines, or IPS cells, from skin cells of people who have these diseases. And investigators say that when a disease-specific phenotype is detectable in differentiated cells, reprogramming technology provides a new opportunity to identify disease-associated pathways and drugs that can block them. So, by studying the differences between normal and diseased cells, the researchers can better understand what causes the cells to die and identify key points in the process that may lead to treatments to change the course of the disease. So there is a lot of hope out there.
Yeah, there is. And plus, that's a really great application for IPS cells that doesn't involve implanting them into people. So,
right.
Good stuff.
All right, guys. Well, what are you doing?
I got one more plug.
Oh.
I got one more plug to make.
All right, what is it?
This is a surprise for Melissa. She didn't know I was going to do this. If you guys are not reading Ted Sand's blog, you need to take a look, because he posted a post recently that was so funny.
Is this the boob one?
Yes. It was so funny.
It was very funny.
I mean, seriously.
Click read.
This is the one. This is right here. The FDA weighs in on adipose tissue, and this is the one where Ted talks about. Anyway, you guys should go to the blog, check it out. Ted is a very funny man, and he also explains some complicated science. So
Always love nerdy jokes.
And there's a lot of them in here. So if you enjoy a good nerdy joke, please take a minute and look at Ted's blog. You'll thoroughly enjoy at least this particular post.
Woo!
About the function of
Breast tissue
versus adipose tissue, and if there's any overlap, which according to some people there is not, and there's only one function for a human breast, which probably is news to a lot of men in our world. So anyway, on that note, we're gonna go.
I like these surprises.
Y'all have a fantastic Monday. Thanks for tuning in, and take a look at Ted's blog. You won't regret it.
All right. Good night, guys.
Good night.